Hello everyone and welcome to Higher Computing for Everyone, Lesson 2.1, Understanding Binary. So the purpose of this lesson is, first of all, I want you to be able to look at a binary number and understand what the value of that number actually is. So for example, when you look at a number that looks like this, you should be able to look at it for a few seconds and say, oh, that's 6. So the way you do that is actually very easy. There's nothing hard about binary, you just have to understand a couple key concepts. The first thing that you need to understand about binary is that every binary number is made of ones and zeros, nothing else. So with any combination of ones and zeros, you can form any binary number that you wish. So the next thing is, how do you understand what the binary number actually is? Well, in order to understand that, you need to understand place values. When we count, if I write out a number like, let's say, 329, what I'm doing is I am placing a digit in a column, and each column has a different value. We have the ones column, we have the tens column, and we have the hundreds columns, and so on. So what we're saying here is 300, 20, and 9, and that's how we get our value. Now, this is called base 10, or decimal. That's the term for this counting system. The counting system that we use is based on the concept that every column is going to be 10 times greater than the column to the right. So the tens column is 10 times larger than the ones column, and the hundreds column is 10 times larger than the tens column. So every time you go with a new column to the right, you are multiplying the value of the previous column by 10, and that's how you get your place values. So when we count in decimal, we go 1, then 10, then 100, then 1,000, and so on, and each column is going to be 10 times greater than the column before it. Okay, so that's base 10. Binary is base 2. What that means is that rather than each column being 10 times greater than the column to the right, it's going to be 2 times greater. In other words, it's going to be double. It's going to be twice as big. So when you write out a binary number, like this for example, we can put it in columns just like we normally would. We always have the ones column, and that's true in any base, whether it's base 10 or base 2 or whatever the case is. You always have your ones column on the far right. Now next to that we have the base, whatever the base happens to be. In this case, since we are using binary, the base is 2. Binary is base 2. So now remember, every column is going to be twice as big as the column to the right. So we have 1, then 2. What comes next? Well, 4, because 4 is double 2. Now why is it double? Well, that's because we are using base 2. If we were using base 10, then it would be 10 times greater. Since we're using base 2, it's 2 times greater, so it doubles. So then this binary number is just simply 2. Because there's nothing in the 4's place, there's a 1 in the 2's place, and there's nothing in the 1's place. So this number is 2. So keep in mind how I did that. Every binary number has columns, and those columns have place values, and those place values start at 1 and then goes 1, 2, 4, 8, 16, 32, and so on, and it keeps doubling each time. So when you have that in mind, it's really easy to see why this number is 6. All we do is we put it into columns. This is the 1's place, this is the 2's place, this is the 4's place, and this is the 8's place. Well, we have nothing in the 8's place, nothing in the 1's place, so all we have left is the 4's place and the 2's place. So we have a 1 in the 4's place and a 1 in the 2's place. So 4 and 2 is 6. That's why this number is 6. You add together the place values that have a 1 in them, and you ignore the place values that have a 0 in them. You can pretend that those don't even exist. Let's do another example. So, I'm going to write out a more complicated example here. Okay, so what about this? All we do is we add together the place values that have a 1 in them. So we have the 1's place, that means we have 1. We have the 2's place. We don't have anything in the 4's place, so we can ignore that. And then we have the 8's place. And then we have the 16's place. And then all you have to do is add this together, and you'll have your answer. So that's how you do it. You just add together the place values that have a 1 in them. Now, this explains how you can convert any binary number from binary, base 2, to decimal, which is base 10. Let's look at how we can add together two binary numbers. So for example, let's say we have this binary number and this binary number. How do we add them together? Well, this is a very easy example because you only have a column that either has all zeros or a 1 and a 0. So here, for example, you have a 1 and a 0. You can just say 1 and 0 is 1 and drop it down. 0 and 0 is 0, drop it down. 1 and 0 is 1, drop it down. 0 and 1 is 1, drop it down. Now, without even converting it to decimal, we already have the right answer, and now we can test it. Okay, what is the top number? We have a 1 in the 1's place, nothing in the 2's place, and a 1 in the 4's place. So 4 and 1 is 5. And in here we just have a 1 in the 8's place, so that's 8. And we know that 5 and 8 should be 13. So we can test that. We have 8 plus 4 plus 1, and that's 13. So that's how you do this. Now, what if you have a problem where you're adding together two binary numbers and it's not so simple, where you have, let's say, something like this. You're adding together 6 and, let's say, 7. How do you do this? Well, first of all, you can think of this in terms of just adding together the places that are actually set and then constructing a new addition problem based on that. So we know that 0 and 1 is 1. We know that 2 and 2 is 4. We know that 4 and 4 is 8. And then we have our answer. We just add it together and we have our answer. Now you can do the exact same thing in binary if you want to have the binary answer instead, and we'll do the exact same thing. We'll add together 6 and 7. But this time, rather than writing it out in decimal, we'll write it out in binary. So we have 6 plus 7. Now notice that sometimes I put a 0 in front of the number. That doesn't change its value. You can put as many zeros in front of a number as you want. It's the same thing in decimal. If I write, for example, this, it's still 21. I could put as many zeros before the 21 as I wish. It doesn't change the value. The same is true in binary. So the reason you put a 0 in front is just to make it easier to read. So here we have the same problem, 6 plus 7, but we're going to do it a little differently. We're going to say 0 and 1 is 1. 2 and 2 is 4, but we're going to write 4 in binary, which means a 1 in the 4's place. And then 4 and 4 is 8, which we're going to write by putting a 1 in the 8's place. We've written out the same problem basically, but now we can just drop down the digits and we have our answer in binary without ever having had to convert it to decimals. So once you are familiar with looking at a binary number as being places that are either turned on or turned off, if there's a 1 in a place value, it's turned on. If there's a 0, then it's turned off. So once you can think of it like that, it's very easy to think in binary. If I want the number 8, I just put a 1 in the 8's place, and now I have 8. If I want the number 9, well, it's going to be a 1 in the 8's place and a 1 in the 1's place, because 8 and 1 makes 9. If I want 12, then I'm going to have a 1 in the 8's place, a 1 in the 4's place, and nothing in the 2's or the 1's place, because 8 and 4 make 12. Now, it's very useful to memorize the binary numbers from 0 through 15, and it's very easy to do this. Start by writing 4 zeros. When you write out 4 zeros, that's of course 0, and the next number is of course 1, which is just a 1 in the 1's place, followed by 2, which is a 1 in the 2's place and nothing in the 1's place, and now 3. How do we get 3? Well, we just add 1 to our previous number. 2 and 1 makes 3. We get 4 by putting a 1 in the 4's place. We get 5 by having 4 plus 1. We get 6 by having 4 plus 2. And that's how you do it. Now, notice that there is a pattern developing. If you look at the 1's place, it's always alternating 0, 1, 0, 1, 0, 1, and so on. In the 2's place, it's the exact same thing, except there's 2 zeros and then 2 1s and then 2 zeros and then 2 1s. So the next thing would be a 1 here, following that pattern. And of course in the 1's place, since it goes 0, 1, 0, the next thing would be a 1 here too. Then in the 4's place, there's 4 zeros, 4 1s, 4 zeros, 4 1s, and so on, so we know the next thing is going to be a 1. And in the 8's place, it's going to be 8 zeros, and then 8 1s, then 8 zeros, and 8 1s, and so on. So we know here that there are 7 zeros, so we need another 1. And that is how you can easily take any binary sequence, and by following the pattern you can count as high as you want. You really don't have to convert each binary number to decimal along the way. Okay, so let's recap here. I know that that was a lot of material very quickly, and it actually is not difficult. Binary is very easy. It's simple addition. So if you have a number like this, all you do is you say you have a 1 in the 1's place, plus you have a 1 in the 2's place, that means 2, plus you have a 1 in the 8's place, 8, so we know this is 11. That's all you do. You just add together the place values that have a 1 in them, and you ignore the place values that have a 0 in them. So there you go. I hope that helped you to understand the basics of binary. I highly recommend that you practice yourself, and in order to make that a little easier, I'll give you a simple exercise here that you can pause the video, and then I'll show you what the answer was. Okay, so pause the video, and remember, here are the steps that you're going to do. You're going to first of all figure out which place values have a 1 in them. You don't have to worry about the place values that have a 0 in them, just the place values that have a 1 in them. You're going to remember that the far right place is always the 1s, followed to the left by the 2s, then the 4s, then the 8s, and then the 16s, and then the 32s. So you're going to add together the places that have a 1 in them. So pause the video, and in a few seconds I'll show you how to do it. Okay, so all you have to remember here is that you have a 1 in the 2's place, you have a 1 in the 4's place, and you have a 1 in the 32 place. So it's just going to be 32 plus 4 plus 2, which is 38. So there you go. That's all there is to binary.